day of our surface area and volume chapter. Surface area and volume, from there we have already completed up to our exercise number 13.2, question number 3. And today we will start from question number 4. So let's start. We don't want to waste time. Let's start with question number 4. This is our exercise number 13.2. Okay. So let's see the question. A pen stand made of wood is in the shape of cuboid with 4 conical depressions to hold pens. Okay. So it's a cuboid with the 4 conical depressions to hold the pens. The dimensions of the cuboid are 15 cm, 10 cm by 3.5 cm. So length and height of the cuboid has been given. The radius of each of the depression is 0.5 cm and the depth is 1.4 cm. Okay. So for each pen stand there is a conical depression. Each pen stand having a conical depression. For this conical depression, the radius is 0.5 cm and the height is 1.4 cm because depth in height also. And for the cuboidal pen stand, length given 15 cm, breadth is 10 cm and height is 3.5 cm. Okay. Find the volume of the wood in the entire stand. Achha. Question is that how many conical depressions are there to hold the pens? Given in question, 4 conical depressions are there. So 4 into this one. So in this cuboid, there are these 4 conical depressions. So now the question is that to find out the volume of the entire stand. If you want to find out the volume of the entire stand, actually the conical depressions are there in that part actually hollowed out. That conical depressions, that particular wood is hollowed out actually. So now if you want to find out the volume of the stand, then what you have to do? From the volume of this cuboidal stand, total cuboid, from the volume of the cuboid, you have to subtract 4 times the volume of the cone. Correct? So what do you write? Volume of entire stand equal to volume of cuboid minus volume of 4 conical depressions. Okay. Volume of cuboid, what is the formula? Length into breadth into height. And 4 conical depressions. One cone volume is 1 by 3 pi r square. As there are 4 conical depressions are there, that's why 4 are multiplied. And why I have subtracted from the cuboid the 4 conical depressions? Because there are 4 conical depressions in the cuboidal stand, it has told in the question. That means 4 conical depressions are there and in that particular part is hollow. That particular cones are actually hollow. So from the cuboid, if I subtract the 4 conical depressions, then I get the entire stand volume right now. What is L? 15, breadth 10, height 3.5, 4 into 1 by 3 into pi into 22 by 7. I think no value of pi has given in question. No. So you have write 22 by 7. R square is coming 0.5 square and H is coming 1.4. So this much centimeter cube as it is volume. Now I think you can calculate it to find out the answer. So this part you will do yourself. I think you understand this one. Okay. So now we are moving to the next question. That is question number 5. Question number 5. What is the question that you see? A vessel is in the form of an inverted cone. Okay. A vessel is in the form of an inverted cone. This is the inverted one. Its height is 8 centimeters. So the height of the vessel is 8 centimeters. And the radius of its top, which is open test, this radius is 5 centimeters. Okay. It is filled with water up to the brim. Filled with water up to brim. So it is completely filled with water. Okay. When lead shots, each of which is a sphere of radius 0.5 cm, are dropped into the vessel. Okay. Each of the lead shots, we are just showing here. Each of the lead shot having the radius. What is that radius? 0.5 centimeter. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped in the vessel, 1/4 of the water flows out. And for that, whenever you have dropped in it, then how many? Suppose n number of spheres, n number of lead shots you have dropped in, because it has not told that how many lead shots. It has told in the question each lead shot having the radius 0.5 centimeter. So each of the lead shot is looks like a sphere. That is also told in question. So each lead shot having the radius 0.5 centimeter. But question is that how many lead shot has dropped in it. So I have chosen that n number of lead shot has dropped in it. And what has happened? For that, 1/4 of the water flows out. So water flows out. How much? 1/4 of the volume of coal. This conical vessel contains how much water? That is actually the volume of the conical vessel. 1/4 of the water it contains came out due to the dropping of n number of lead shots in the conical vessel. Question is that find the number of lead shots dropped in the vessel. How many lead shots has dropped in the vessel? That one we have to find out. We have now the Archimedes principle in class 9, density chapter. There we have learned that how much water has displaced out due to the immersion of all those lead shots. N number of lead shots you have immersed in the water, you have dropped in the water, and due to that 1/4 of the water, 1/4 of the volume of the conical vessel, that water has came out. This water volume should be equal to the volume of this n number of lead shots. So this n number of lead shots total volume should be equal to the volume of 1/4 of the water which has came out. Why? Because this water has came out due to the dropping of these all lead shots. And by Archimedes principle you know they will displace the equal amount of water according to their volume. So now first of all we will write let n number of lead shots dropped in the vessel. N number of lead shots has dropped in the vessel. Now according to question, volume of n number of lead shots equal to 1/4 into volume of conical vessel, because conical vessel contains how much water? 1/4 of the water came out due to the dropping of n number of lead shots. Equal, that is n number of lead shots is n into each lead shot is a sphere. Each sphere having the radius 0.5 centimeter. So what will be the volume? You know the volume formula, 4/3 pi r cube. Now for conical vessel, what is the formula? 1/3 pi r square h. R means 5, h means 8. This 3 can be cancelled from both sides. Pi also can be cancelled from both sides. So it's coming n into 4 into 0.5 whole cube, that is equal to 1 by 4. This can be cancelled, put to the end. It's coming 5 square into 2. I think you can calculate it to find out the value of n. If you can find out the value of n, then you can write the final answer. Therefore, that many number of lead shots has dropped in the vessel, due to which 1/4 of the volume of 1/4 of the water has came out. I think you can complete it. So solve this equation to find out the value of n and write the final answer yourself. I move to the next sum. Actually, my work is to show you that how to do the sum. The calculation part is completely your job, because you have to remember the area related to circle, then this surface area volume. This chapters actually crucial part is the calculation. So do the calculation as much as possible to learn, to make it a habit. Okay. So now we are going to do the question number 6. Number 6. A solid iron core consists of cylinder of height 220 cm and base diameter 24 cm. Okay. So this is a solid cylinder whose height is 220 cm. Sorry, 120 cm. And sorry, 120, 220 cm. Sorry. And the base diameter 24. So what will be the base radius? 24 by 2 cm. So it will be 12 cm. Okay, next. Which is surmounted by another cylinder of height 60 cm and radius 8 cm. Surmounted by another cylinder whose height is 60 cm and the radius is 8 cm. So this one we are denoting by capital R, this side we are denoting as capital H, and this one we are denoting by small h. Okay, next, find the mass of the pole given that 1 cm cube of iron has approximately 8 gram mass. Acha, 1 cm cube, that means they are talking about the volume. 1 cm cube having a mass 8 gram. So if I can find out the volume of this pole, then iron pole, iron pole though, mass of the pole, yes. If I can find out the volume of this complete pole, then by multiplying the mass I can find out the total mass of the pole. Because 1 centimeter cube having the mass 8 gram. So how much centimeter cube will come as a volume of this? And multiply 8 with that to get the mass of this pole. So that's why I have to find out the volume of this pole. Very easy to find out. Volume of this pole means volume of this cylinder plus volume of this cylinder. You know the radius and height of this cylinder, so you can find out the volume by using the formula pi r square h. You can find out the volume of this pi r square h. By adding them, you will get the total volume of the pole, and then multiplying the mass, because 1 centimeter cube having the mass 8 gram. So by multiplying 8 gram with it, you can get the total mass. And if the value will come too much bigger, just change the gram to kilogram. Clear? So this sum I am not do is completely your homework. I have explained only. As you know the radius and you know the height, pi r square h is the formula. So how you write? You write the total volume of the pole equal to pi small r square into h plus pi capital R square into h. Then you put the values, calculate it, find out in centimeter cube. Then you write mass of the pole at the rate of 8 gram per centimeter cube equal to 8 gram into this one. Then you find out in gram, and if it will come too much bigger, then you convert it into kilograms. Okay? So complete it yourself. I'll move to the next sum. Now, question number 7. A solid consisting of a right circular cone of height 120 cm and radius 60 cm standing on a hemisphere of radius 60 cm. So this is the hemisphere on, and you just see the radius of the right circular cone, first line you see properly. Radius of the right circular cone is also 60 and radius of the hemisphere is also 60. That means the cone will be like this on the hemisphere because both of them have the same radius. Okay, so H to H it will match. And what is the height of cone given? Height of the cone given 120 centimeter. Height of the cone is 120 centimeter. Okay. Place upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and height is 180 centimeter. Achha. So what has done? Again we are just reading this one. Placed upright. Okay. So what has done? This solid has kept in a cylinder. And the height of the cylinder given 120 centimeter. Once we check what is the height of this one, this is 120, this is 60, means this also will be 60 because this is the radius of the hemisphere always will be same. Then this 60 if I consider here, then the total height of this particular solid is coming 120 centimeter, 180 centimeter because cone height is 120 and this radius is 60, means if I consider together, it will become 180 centimeter. And we just see that cylinder height has also told in question 180 centimeter. So what we can say from here? If we keep the solid, in this cylinder, actually it has told that whenever we will keep it upright in the cylinder, this solid will touch the bottom of the cylinder. Very good. If the solid will touch the bottom of the cylinder, actually this height is total 180 centimeter. I have checked before. This is 120 and this is 60, means total 180. So whenever we keep it in the cylinder, so that this hemisphere should touch the bottom, just like we are keeping upright, then the top vertex should touch the top of the cylinder also. Correct? And also it has told in question that the radius of the cylinder is also 60 centimeters. Radius of this also 60 centimeters. That means whenever I will keep this one in the cylinder, it looks like this. It looks like this. This one is 60 centimeter. This height is total 180 centimeter. And radius everywhere is 60. And this cone height is 120 centimeter. Okay, now what is the question actually? What I have to find out? The question is, find the volume of the water left in the cylinder. Achha. Whenever we keep like this, whenever we keep this solid in the cylinder, then how much water is left in the cylinder, that one you have to find out. So how to find out, I think you can understand, you can guess. I'll find out the volume of the cylinder and I'll subtract the volume of this solid from it. From the complete volume of the cylinder, if I subtract the volume of this cone and this hemisphere, then definitely I get the volume of the remaining part which is not occupied by them, and that part of the water is there. So how much water is there in the cylinder? That should be equal to volume of the cylinder minus volume of this complete solid. Okay, so how will we write it? Volume of water present in the cylinder. So one thing you have to remember, if you will not give the diagrammatic representation properly, then you have to mention and you have to explain everything in the statement form. That's why you are not writing a lot of statement, as we are giving the proper diagrammatic representation. Okay, so volume of water present in the cylinder, that is equal to volume of cylinder minus volume of the solid. That means volume of cylinder minus volume of solid means volume of cone plus volume of hemisphere. Volume of cylinder, what is the formula? Pi r square h. So these 60 centimeter we are taking as r. So everywhere the radius is same. Minus volume of cone, formula is 1/3 pi r square h, but this height is different because cylinder height is 180 but cone height is 120. So this height we are just writing as capital H plus volume of hemisphere. What is the formula? 2/3 pi r. This radius are always same, that's why all we have noted by smaller. From each of them I can take common pi r square. So what will remain here? Small h minus capital H by 3 minus 2r by 3. Now we can put the values. Pi mean 22/7. I think more specific value of pi has given in question. Yes. So you can put it 22/7. R mean 60. H mean 180. Capital H mean 120/3. 2r. This means 2 into 60 by 3. So it's coming 22/7 into 60 square. 180 minus 340 minus 40. I think the leftover calculation you can do yourself to complete it. Okay? So this remaining what you do, and the answer will come in centimeter cube definitely because all is given in centimeter. So I think understand that what is the main theme of the sum. Why I have done the cylinder volume minus this complete solid volume. Why? Because in the cylinder, whatever the empty space is there, how can I get it? From the complete cylinder, if I subtract the volume of the solid, then the remaining one will be the volume of the water, because in the empty space only the water is present. Okay? Now we go for question number 8. Ask has a cylindrical neck 8 cm long, 2 cm in diameter. Spherical glass vessel having a cylindrical neck, and this neck having height 8 cm and radius is 2 cm. This is smaller, this is h. The diameter of the spherical part is 8.5 cm. The spherical part volume diameter is 8.5 cm. So radius will be 8.5 by 2 cm. This one we are using capital because it is different from the small one. By measuring the amount of water it holds, the child finds its volume to be 345 cm cube. Check whether she is correct, taking the above as the inside measurement and pi equal to 3.14. So they have already told to take pi equal to 3.14. And some of what has done, it has told in question that by measuring the amount of water it holds. So now you just see, and it has been 345. The question is that the child is correct or wrong, that one we have to find out, considering pi equal to 3.14. Look here, how much water it holds? That's been actually the volume of the sphere plus volume of the cylinder. So what do you write here? Amount of water it holds equal to volume of sphere plus volume of cylinder. Volume of sphere, what is the formula? 4/3 pi r cube, capital R we have taken. Volume of cylinder, what is the formula? Pi r square h. So 4/3 pi you can take common. 4/3 capital R cube will be 8.5 by 2 whole cube. Small r square means 2 square and h means 8. This much centimeter cube. You have to put here pi equal to what? 3.14. It's 8.5 by 2 into 8.5 by 2 into 8.5 by 2 plus 4 is the 32. I think the calculation part you can do. So calculate it and find out the answer. If it comes slightly more than 345 also, then you can say the child is wrong. Because the child has given the answer 345 centimeter cube is the polygon. If your answer is coming slightly more than 345 also, because here no approximation should be done by you. Why is it so? Because you just see it's already given 3.14 and here given 3. Suppose you cannot do the cancellation. Suppose the complete cancellation is not possible. In that case, you find out the answer approximately after 2 decimal places. And after then you check what is the child's answer. The child has given what answer, and what answer you have got is completely matching or not. If it is not, then you write the child is wrong, and if it is coming completely 345 centimeter cube, then you say the child is correct. I think it will not come 345 because 3 is here, which cannot be cancelled. I think so. So once you check it, complete the calculation, and the final conclusion you write. I think you can complete it yourself. Okay, so today we are completing our class with this only. Next day we will start from exercise number 13.3. Thank you.